this is just a quick video on combining like terms. And across the top here, you see all different types of terms here. We look at them as constant terms or variable terms and how we would combine them. We're going to use that learning to simplify expressions. So across the top here, you see terms with like this is an x term because it's 8 times x, so we would count it as an x term. And this is 4 times y, so we call that a y term. And when we add and subtract, we don't combine those. They're separate. So they're not considered like terms. But 6x is a like term with 8x, so we would put that into this category. And 12y is a y term, so we put that into this category. But this -3 is just a constant term. It doesn't have a variable, as is -5 and +2. They don't have variables. And then this last term here, well, this is an x term. So I've separated the terms just to get you thinking about how you might combine like terms. You can only combine x's with x's when you're adding and subtracting, and y's with y's when you're adding and subtracting, and constant terms with constant terms. So over here, we'll just make up an example with some of these terms here. So if I take 12y and I add that to 2, then I can subtract 6x if I want, and then I can subtract 4y, and I can add a -5. So I've just made a problem here. Let's just kind of group that problem and move it down and focus on just that problem there. So one thing to think of is, what are the like terms? So if you think about the page before, we had the x terms, the y terms, and the constant terms, and that's how we're going to do this problem. The goal to simplify the expression. That means you want to take your expression, and in the end, you only want to have one x term, one y term, and one constant term. And right now we have 2 y terms, 1 x term, and 2 constant terms. One of the things that I like to do is just use like shapes or color and identify the like terms, like 12y and 4y. But if you notice, I circled the subtraction in front of that. That subtraction also acts as like a -4y. So if I focus just on those terms and I think about in my head, like, what is 12y minus 4y? I get 8y. So that gives me an 8y. And now I'm done with those terms. So I'm going to pick up another color here, and I'm going to think of this as +2 plus a -5. So if I just think about that for a minute, I have 2 plus -5, which is -3. So that -3 becomes a subtract 3. And now the only thing that I have left is that -6x, and since it doesn't have to be combined with anything, there's no other x terms, that's my simplified expression. But usually we arrange it alphabetically. So and the reason we do that is just it makes it easier to compare answers. So -6x plus 8y, because that 8y is positive, minus 3 is the simplified expression. So that's not to say that this expression here is incorrect. They're both considered simplified, but the alphabetical is kind of what you will see in most like answers, because it's easier for everybody to check their work with one another if they all agree on an order. So let's make up a second example here. So I could say -5 minus 8x minus 12y plus, I don't want an 8x, let's plus 6x plus 2 plus, let me move all that over or down, plus 4y. Now I'm going to simplify that expression. So I'm going to go through the exact same process. I'm going to circle my like constant term. So I have -5 plus 2. And you can even think of rearranging it if it helps you. And that gives you -3. And then we have -8x plus 6x right there. So -8x plus 6x, that's a -2x. And then we have -12y plus 4y. And that gives you -4y. So now I have one x term, one y term, and one constant term. So when I rewrite my final answer in alphabetical order, -2x minus 4y minus 3, that's my final answer. So let's just make up another one. We'll do maybe one with a little bit more negative challenge. So 4y take away, and then a -3x. So we'll put parentheses here. And then plus -3 minus 12y plus 8x minus 5 minus 6x. So go back to just thinking about like terms separately. So I'm going to start with the y terms. 4y minus 12y. So 4y minus 12y. That's a -8y. And then, like when I see subtract a negative, we can think of that as adding a positive. So if I just copy the whole problem down again, to clean that, whoops. To clean that up, that would just be the same as plus 3x. So that's a plus 3x right here. And then we have a plus 8x and a minus 6x. So plus 3x plus 8x minus 6x. And when you think of that, 3 plus 8 is 11, take away 6 is 5, so you have a positive 5x. from there. And then you have your numbered terms, so plus a -3. So this right here, that's like subtract 3, because adding a negative is the same as subtracting a positive. And then we have -5. So if you think about -3, like 3 below 0, and then taking 5 more away, you have -8. So to finish this off in alphabetical order, 5x minus 8y minus 8, your final answer. And this last one, we're going to put in distributive property. So this is kind of a little bit bigger challenge. So 2, then parentheses, (6x) plus, that's a big addition sign. Okay, it's a little bit better. So 6x plus 2 minus 8x minus -5. So here we have some parentheses. One thing with distributive property that we've talked about is you could treat this like the area model. 6x plus 2, that's 12x, because 2 times 6 is 12, so 2 times 6x is 12x, and then 2 times 2 is 4. So this is the same as 12x plus 4. Then we still have subtract 8x, and subtracting a negative, that is like adding a positive, so plus 5. Now we can find our like terms. 12x, take away 8x, is 4x. And then positive 4 plus 5 is 9. That's the final answer. So that's just a kind of summary of how to use combining like terms to simplify expressions.